Today's activity is not unlike, in a lot of ways, the one that you did last week. We're going to be finding the velocity of a car that's moving at a constant velocity across the horizontal floor. Now, the car that you use will be different, and the way that you measure the velocity will be different, but in essence, it still boils down to the same thing. The problem would be, what is the velocity of a car traveling at a flat, horizontal surface? Now, today we're going to talk, for this activity, we're going to talk about our three variables for the first time. We didn't do that last week, right? We skipped that part of it. There are three variables here. There's the manipulated variable, there's the responding variable, and there's the control variables. One manipulated, one responding, and one control variable. I'll tell you now, okay, I will tell you now that you're going to end up plotting a graph just like you did last week. Just where you get the data from is going to be a little bit different. The graph is going to look like this, position versus time. Now, looking at that graph, you should be able to tell me right now which is the manipulated variable. Yep. Good. The x-axis is always the manipulated variable. The y-axis is always the responding variable. And then your control variables, well, it's everything else. Now, I'm not looking for something as detailed as, you know, the sun shining at the same angle from one trial to the next, right? I don't care about that. Okay? I mean, strictly speaking, everything should stay the same from one trial to another trial or one test to another test. But in the end, what we're looking for is the important stuff. Okay? Make sure you're using the same cart. Okay? Make sure you're using the same this and that, right? The important stuff that stays the same from one trial to the next. Now, your apparatus is going to look more or less like this with one small change that I decided kind of last minute, to change. This is the cart that I was going to have you use. That's the cart that you used last time, right? We're going to have you use something different this time. There's some dynamics carts that I'm holding up, one dynamics cart that I'm holding up right now with my hand. This is what you're going to use this time. This one, you're going to have to actually send down yourself. You're going to have to propel it down. But don't hold on to it. Just push it down. Okay, measure it, measure the velocity of it as it's traveling downwards, down the floor at a constant velocity. Now, how are you going to measure that velocity? We don't have 10 different timers set up at stations to measure the velocity. So what we're going to do is use this little device right here that's called a motion sensor. That motion sensor will be connected by a wire to this thing right here that we call an air link. This air link will be connected wirelessly to your iPhone. When you press start, this motion sensor will collect position time data, okay, position time data for this cart traveling at a constant velocity along the floor. That position time data will be transferred to this AirLink apparatus, which will in turn transfer it via Bluetooth to your iPhone, wirelessly to your iPhone. You will see the graph on your iPhone instantly, real time. As the cart is still traveling on the floor, the graph will be automatically plotting on your iPhone. Does that make sense? All right. There's a couple little things. First of all, you may see the graph looking something like this. What would this correspond to right here, do you think? Tell me what that would correspond to. Obviously, we don't want that data. Why don't we want that data? What does that data mean? What's happening there? It's not moving. So you started it before you pushed it. That's okay. Just delete that data if that's the case, right? Okay, all we want is the data that corresponds to the constant velocity, which should be right here. Now, another thing is, This motion sensor that you see right here has two settings on it. One setting is for a guy walking. And one setting, can't see this real well, one setting for a guy walking, one setting for a little cart. You want the setting for the little cart. Now, you can set it for the guy walking if you're trying to measure the velocity of something big and far away. If you want to measure the velocity of something small and close, we want to have it on the cart. And that's what we're trying to do. So that's the setting you want to make sure it's on. In all likelihood, it's on that setting right now. But if it's not, then I want you to make sure that it is on that setting, okay? So what's our procedure look like? Procedure's pretty straightforward in the end. Okay? You're going to set this whole thing up, and there's an instruction sheet as to how to set that up. You don't need to give me the details when you write out the procedure of, you press this button, you press this button, you paired it via Bluetooth, blah, blah, blah. I don't need all those kind of details, okay? Okay, that's kind of like saying, I was performing a lab, I broke my pencil lead, I went back and I sharpened my pencil. My pencil was too sharp. I went to my desk. I got another pencil. It didn't work. So I asked my friend for a pen. You don't need that kind of detail in a lab write-up, right? We don't need that kind of detail here either. Okay? You need to set this apparatus up. I'll assume that we know how to do that. Okay? We don't need to write out those kind of details in the procedure. What you do need to write in the procedure is essentially this. Your cart, okay, is going to be set in front of the motion sensor at rest. You're going to give it a push. You're going to press start on your iPhone so as to measure the position and time data for that cart as it's moving at a constant velocity. Then you're going to press stop. And then you're going to send the data, email the data to yourself and perform the analysis. That's essentially it. Now, what I do want you to do is do a few trials. Okay? You've got time today. Do 2 or 3 or 4 trials. Okay? When you have a trial that gives you the best graph, the best straight line on the graph, it can have all that stuff ahead of time, right? It can have this. I don't care about that. Okay? Pick the one that has the best straight line on it. Even if it has some other stuff before, even if it has some other stuff after it, I don't care. Pick the one that has the best straight line somewhere in the graph. Email that data to yourself. Delete the data that doesn't matter, this stuff, and then do your analysis, which I'll show you how to do after you've collected your data. Okay, I don't want to overwhelm you right now with how to do the analysis as well. Once you get that data emailed to yourself, you're going to see a table that looks something like this. Time in the first column, because that's our manipulated variable. Position in the second column, because that's our responding variable. Whole bunch of times, whole bunch of positions. Now, the last time you did activity, you had to label it for which car it was, right? The blue car or the red car. Since you're only showing me one this time, you don't have to do that. You don't have to say blue car data. Okay? It's your data for the only car you have. Your analysis will consist of a graph, position versus time. Don't forget to put a title for it. You will have, by this time, deleted the data that's not relevant. That flat line before we started moving it, maybe a flat line after it stopped. Delete all that data so that you have only the straight line data. Use Google Sheets to calculate, to plot a line of best fit. Use Google Sheets to calculate the slope for you in the form of y is equal to mx plus b. It might be y is equal to 3.2x plus 0.4. Okay. That's your velocity, right? Your conclusion will be the velocity of this car was 3.2 meters per second, whatever number that works out to be. This is known because the slope of a position time graph is 3.2. So What did you find out? How do you know? The velocity of the toy car is 3.2 meters per second. This is known because the slope of the graph, position time graph, is 3.2. Sources of error, come up with 2 or 3 good sources of error. It could be issues with the procedure. Maybe something could have been better with the procedure or the materials. It could be something with your time management, okay, how you manage things. It could be something with just about anything. Okay? Anything that could have been done better. Okay? Identify 2 or 3 good things that could have been better, and then give me a possible solution for them. So this is how we would do it next time that would be better. This is the problem. This is how it would be better. So what are we going to need to hand in for this one? Problem, which I've already done for you. Your variables. You need materials. I'll tell you one thing. You don't have to do this. My suggestion for materials, when you're doing this, take a picture. Take a picture of what you're doing. That way you're not going to forget a material, right? Because everything's going to be right in front of you. You can't forget something if you take a picture. What I would do, I'd take a picture. I'd actually insert that picture into my document and then just label the picture. Make sense? And you don't have to do that. I don't need to see the picture. Man, for you, it helps you to not make a mistake in forgetting something, right? Oh, I forgot that I used the air link. Well, you're not going to forget that you used the air link if you see a picture of it right in your document. You need a procedure. Remember, one of the things that people did in the last activity was they forgot to number the procedure. They just listed. Okay, that's good, but better is to number them. Step 1, step 2, step 3, step 4. You need your data, you need your analysis, and you need your conclusion and sources of error. So essentially, the only thing that you don't have here that you're used to doing in Science 10 is your hypothesis. We're not doing a hypothesis here because of the nature of this activity. You're trying to find a velocity of a car. If you try to predict the velocity of this car, it's not a hypothesis. It's a guess, right? It doesn't make any sense really to guess what the velocity of this car is going to be. So full lab write-up on this one, minus the hypothesis. Problem, variables, materials, procedure, data, analysis, conclusion, sources of error. You got that? Okay, one final little thing. We'll go back to this for a second. Right now, you're thinking to yourself, like, well, how exactly do I use this air link? And how do I set it up with my phone and that sort of stuff, right? You don't know yet. That's okay. Okay, I haven't explained that. There is a handout that you're going to get when you take your apparatus up here that you need to follow to the letter. It's not confusing. Okay, it's very, very clearly written. If you have a question on it, I'll be happy to answer a question. But what you need to do is make sure that you follow those instructions to the letter. The app that we're going to use to collect this data is glitchy, very glitchy. If you follow the instructions that I've come up with, I've spent hours like trying to come up with the best order of doing stuff. And if you follow those instructions to the letter, it works. If you do something before you do something else out of step, it might be glitchy on you. Okay, it might freeze up. It might give you trouble. So don't do that. Do everything in exactly the way it's written on that sheet, in the exact order. Do everything. Don't skip a step. Do everything. You shouldn't have a problem, right? And if there's any questions as you're going, then by all means, you can feel free to ask it. All right? Any questions right now? Okay, let's get at it.